Okay, so today we're going to actually be learning how to use matrices to solve a system of equations. Okay, so the thing that we will need to know how to do is to find the determinant of a matrix. So for a 2 by 2 matrix, there is a formula for finding the determinant. So if you look, the vertical bars around a matrix does not mean absolute value. It means you're finding the determinant of the matrix. This first element will represent A, B, C, and D. That would be the order that your elements will be in. To find the determinant of a 2 by 2, you're going to do A times D minus B times C. So you're going to multiply these together, subtract, and multiply those two together. Okay, so that's what we're going to do in example 1. Sometimes it's not going to tell you find the determinant. You're just going to need to know that those vertical bars around a matrix means find the determinant. Okay, so this is A, B, C, and D. So we're going to use the formula that we just talked about. So A times D, so 3 times negative 2, minus B times C, so that would be negative 6 minus 5, which equals negative 11. So when you're finding the determinant of a matrix, you should be getting one number for your answer. Okay. Let's look at example 2. So we're doing the same thing. We're finding the determinant of this 2 by 2. So I'm going to use the formula. So negative 2 times a negative 7 minus 5 times a negative 1. So that's going to be a positive 14. And then a negative 5 times a negative 1 is a positive 5. So you should get 19. So when you have a 2 by 2, multiply these and multiply those, subtract the two answers. Make sure you're subtracting. All right, so the next one, example 3, we have a 3 by 3 this time. Okay, there's a different formula for that. On the 3 by 3s, I'm going to show you how to use the calculator to find the determinants. Okay, so on the back of these notes, you will see that there's instructions on how to use the calculator, so you can refer back to those if you need help. But to enter in a matrix in the calculator, you're going to do second and then x to the negative 1 power. It's right below the math button. And then you should see this, okay? So to enter in a matrix, you're going to go over to edit. I'm going to type this matrix into matrix A. And you have to type the order in. So it's a 3 by 3. You can just type over what's already in your calculator if you have something already entered in. And then you're going to type in all of your elements here. So 2, 3, 1, 5, negative 1, 0, 0, 1, negative 3. So there's your matrix. Once you've found the matrix, or once you've entered in your matrix, you're going to find the determinant. So you always have to be at your home screen. So second quit or second mode takes you back to your home screen. You're going to find the determinant by doing second matrix, so back to that x to the negative 1 button. And then you're going to go over to math, and then number 1 is DET, which is determinant. I typed my matrix into A, so I'm going to find the determinant of matrix A. So to recall on matrix A, we're going to do second matrix, and then you're going to name that whatever matrix you're talking about. So the determinant of A would give us positive 56. So again, if you're finding the determinant, you should be getting one number. Okay, so now we're going to use that. We're going to use that to use Cramer's rule to solve systems of equations. Cramer's rule means you will be using determinants to solve the system. Remember, we're solving a system. We've already gone over using graphing, using substitution, and using elimination. When you're solving a system, you're trying to find the point that they have in common. So that's what we're trying to do on this first example that we have when we're solving. So notice we have 2 variables and 2 equations. That's a system of equations. We're going to be using the determinants, which we just learned how to find in the front. What we're going to do is we're going to set up 3 different matrices. It tells you on your notes step by step of what to do. So this first matrix, the first column, I'm going to fill in the coefficients of x. So I'm going to look back at my two equations that I have. Coefficients are numbers that are in front of your variable. So the coefficients of my x are 4 and 3. The coefficients of the y are 3, and that's a negative 1. So there's my first matrix. My second matrix I'm going to use to solve for x. That's why there's that little x there. So in the x column, which is the first column, I'm going to put my constants. Remember, constants never change. So those are the numbers without a variable. So negative 4 and negative 3. The second column, we will put our coefficients of y, so 3 and negative 1. The third column, or the third matrix that we're going to set up, we're using that to solve for y. That's why there's that y there. So in the y column is where I will put the constants, which will be your second column. So the first column, I need to put the coefficients of x, so that was 4 and 3. And then the second column are your constants, so that would be negative 4 and negative 3. Okay, so now what we're going to do, once we've set up our three matrices, we're going to find the determinants of each one. Remember, to find the determinant, the formula for 2 by 2 is AD minus BC. So this first one, I'm going to do 4 times a negative 1 minus 3 times 3. So that's going to be negative 4 minus 9, which would equal negative 13. Okay, so then finding the determinant of the second one, negative 4 times a negative 1 minus 3 times a negative 3. So that would be 4 plus 9, which would give you positive 13. And then this last one, that would be 4 times a negative 3 minus a negative 4 times 3. So negative 12, that would end up being plus 12, which would equal 0. Okay, so now we're going to fill this in. Determinants of each matrix. This first one was the determinant was negative 13, so I'm just going to fill that in here. The second one we found to be positive 13, and determinant of that last matrix was 0. So once we find the determinant of each one, this is how we solve and find the solution. To find x, you're going to take the determinant of the dx, which was your second matrix that you set up. We got 13. Determinant, you're always dividing by the determinant of the very first matrix that you set up on all problems. Okay, so determinant of that first one was negative 13. So when you divide it, you get negative 1 for x. For y, we're putting the determinant of dy, which was the third one. So in the y column are where your constants go. So that determinant was 0 over always that first one, negative 13, which would equal 0. So remember we said to find the solution, you're finding the point that they have in common. So make sure that you write it as an ordered pair. So that would be negative 1, 0. And then we could check it by plugging that in, the x and y, plug it in, and make sure that it's true on both equations that we have. Okay, so looking at the next example when we're solving, notice this time we have an x, y, and z, and 3 equations. Okay, so this time we're going to be solving, we're going to be trying to find x, y, and z. Remember, that's called an ordered triple when you find the solution or the point that they have in common. Okay, all right, so we used elimination last unit, or substitution is what we used in order to solve this type of system. So since we have 3 equations, we're going to be setting up 4 different matrices. The last one we had 2 equations, so we set up 3. On your notes, it tells you exactly how to set it up. The first column will be all of your coefficients of x. So that would be 2, 3, and 5. Second column will be your coefficients of y. So 2, 2, and negative 2. And then third column will be coefficients of z. So 1, negative 2, and negative 6. The second one, d of x. So the x right there means that we're using it to solve for x. So in the x column is where your constants will go. The constants are just the numbers without the variables. So 3, -1, and 17. Everything else will include the coefficients. So second column, coefficients of y. So 2, 2, -2. Third column, coefficients of z. 1, -2, -6. This third matrix, we're using to solve for y. So in the y column are where your constants go. So the first column will be coefficients of x. See that? That would be 2, 3, and 5. And then your constants will be 3, -1, 17. In that third column are the coefficients of z, 1, -2, and -6. And then the last matrix that you're going to set up will be used to solve for z, so that's where your constants need to go. So that would be coefficients of x, 2, 3, 5, coefficients of y, 2, 2, -2, and your constants 3, -1, 17. Okay, so remember on that last one, after we found each matrix or we set up each matrix, we then found the determinant of each one. So remember on the front, on a 3 by 3, we use the calculator to find the determinant. So right here, I'm going to go ahead and label that I'm going to type this one into matrix A, this one into matrix B, C, and D, so that way I know which one I typed them into. All right, so remember to enter in a matrix on the calculator. You do second matrix, go to edit. I'm going to type this first one into matrix A. It's a 3 by 3. Make sure that you're checking every element that you type into the calculator to make sure that you typed it in correctly. So 2, 2, 1, 3, 2, -2, 5, -2, and -6. So after you typed them in, you might just double check to make sure that you typed them in correctly. Okay, and then I've already typed in B, C, and D, but if you wanted, you could do second, or if you needed to, second matrix, go to edit, and then go down to B to edit your B. And then do the same thing for C and D. So I'm going to go back to my home screen, and I'm going to find the determinant of each one. So remember, this one was A, B, C, and D. It over. Okay. So I'm going to find the second matrix, math, to find the determinant number 1 of matrix A. So second matrix, and then you're naming A. Make sure you're on the home screen whenever you're doing this. So you should get -32. -32 there. And then we're going to do the same thing for the others. So I'm just going to do second, enter, and just enter in that determinant again, and then go back and edit. So second matrix, name B. So -160. +160. And the very last one, second. B, -96. All right, so once we find the determinant of each one, x, to get x, we're going to take that second one, which is d of x. Determinant of that was -160. Your always dividing it by that determinant of the very first matrix that you set up, which is negative 32. So you should end up with positive 5 on that one. On y, we're taking that third one, determinant's 160, always dividing it by the determinant of the first one, which would end up being negative 5. And then to find z, we're using that last one that we set up. That was negative 96, dividing it by that first determinant, which was negative 32. So you should end up with positive 3 for your z. When you're writing your solution, remember of a 3-variable system, you should get an ordered triple. So that's 5, negative 5, and positive 3. To check it, you would plug in for x, y, and z on all 3 of those original equations that we started with.